Question, do you think in number 2, I'm going to start by considering the absolute value?
No.
Or just the actual series itself?
The actual.
Yeah, why? What's the strategy? Why would I start right away with the alternating series test?
Because if that converges, then you have to find out if it absolutely converges or it conditionally converges, but if it diverges, you don't have to worry about any of that.
Exactly. If, like, think of what could happen. If alternating series test says converges, then I can say, okay, alternating series converges, but I don't know if absolute value converges. So converges conditionally, converges absolutely, I don't know, I have to go test. But if the alternating series test diverges, which, does this diverge?
Yes.
Why does it diverge? What is the limit as n goes to infinity? Well, let me zoom in, huh? They're tied, right?
Yeah, so it would just
This is just going back, forth, back, forth, back, forth. What is this going as n goes to infinity? 2. And 2
does not equal 0.
does not equal 0. So I can say, without even having to test the absolute value and say conditionally or absolutely, neither. What is the conclusion? Our alternating series test even says it. First condition that has to be true is the limit as n goes to infinity of the term is 0. And if it's not 0, it diverges. Why? The nth term test. Diverges completely. No conditional or absolute or anything. So I can just say, therefore, basically by the nth term test, the series diverges. Now, if I had done the absolute value, technically, remember up here, I did absolute value when I saw it diverges, but I wasn't done because I had to go and consider the alternating series test. The absolute value diverged, but the alternating series converged, so it's conditionally convergent. But here, if it fails the nth term test, if the limit does not equal 0, then done, diverges. Okay? All right, we have lots more examples. You guys ready? Let's keep doing alternating. How do I know they're alternating? -1.
Did you do p-series?
I could do p-series, because how could I rewrite this? Or what would p be? N to the 1/2. Is that good or is that bad? Oh no! We have to go like this.
It diverges.
Diverges. But wait a minute, what are we doing if we're doing p-series test? Are you guys trying the absolute value, or are you trying the alternating series test?
Alternating series.
But to do alternating series test, how do we do alternating series test? We don't think about nth term or p-series or anything else, we just think about these two. So I think what you guys are thinking of is the absolute value. You're thinking of, I want to ignore. I want to make sure that you understand what you're doing. Because it still has purpose, it's still helpful.
Because don't you, for like the alternating series test, you take the limit as n approaches infinity of a to the n? Because
But a to the n would be 0.
wouldn't a to the n be 1 over n squared root?
Well, no, a to the n would be the whole thing, but this is just flip-flopping back, forth, so I'm looking at him just going to infinity.
Because like the way the forever card makes it sound like you have the -1 to the n term, and then a to the n is just whatever that's not in that.
Is that how I wrote it? I mean, you end up ignoring the -1, you know what I mean?
Yeah,
Because
that's right,
it's
that's
just
right.
flip-flop. But like, we wouldn't use p-series in doing this. Does that make sense?
Okay.
Because this, I would just look at it, and we are going to do that because we need to, and you'll see why in a second, because this diverges, but I need to see if it's conditionally convergent, the alternating series. But if I was doing alternating series, I wouldn't do p-series at all.
do you know when you have to consider the negative 1 to the n?
I have to consider him when I say alternating series test. That is me considering him.
Okay.
Because alternating series tests, I'm saying I realize that he's positive, negative, positive, negative. So I'm not just going to say P series, whole thing diverges. I don't know. P series, I know the absolute value. Absolute value says negative 1 doesn't matter, right? 1 over square root n, it's old-fashioned. P series fails. Or P series proves that the absolute value diverges, but I still have to say, but does this one converge? So to figure that out, first I would take the limit, you're right, as n goes to infinity of 1 over root n, which is 0. First condition, good, right? But that's not enough. I need to check the second condition. And second condition says take the n plus first term and compare it to the nth term. Is this one always going to be for between 1 and infinity, so for positive numbers, 1 to infinity? Is this one always going to be bigger than, smaller than, equal to? Well, not equal to. Smaller than. Why? Because his denominator is bigger, right? Is that good or is that bad? Go look at your test. Good, right? So, what do I know? Because the absolute value diverges, but then according to alternating series, the alternating series converges, then I know that my series is conditionally because alternating series is check, check. Yeah, because alternating series is check, check.
When we use conditionally, when we use absolute.
Yes.
When, so, because yesterday there was an example we used absolutely.
Oh, what do you mean conditionally versus absolutely? Absolutely would be if converges here. If converges here, I don't even have to worry about this. If absolute value converges, then absolutely convergent, I'm done. Because this would be absolutely convergent. But if absolute value diverges, then I have to still see, well, is the alternating series, according to alternating series test, is that okay even though absolute value is not? And that's where this comes in. Because if this converges, then the alternating series is absolutely convergent. If the alternating series converges and the absolute value diverges, we call it conditionally convergent. Meaning it's only going to converge if positive, negative, positive, negative. Right? Yeah. Okay.
So if you know that it's divergent, like from the beginning.
You missed that example, but yeah.
Then
If you know it's divergent from the beginning, then it's completely divergent. Now, not the absolute value, though.
Yeah.
The actual term itself. Yeah.
Okay, cool.
All right, you guys go. You guys go.
What power is the bottom one?
Fourth power. So it's negative 1 to the n minus 1 all over n to the fourth. Bring up my files, but Ethan's not here, so we'll wait and do it tomorrow. I have papers to pass back. Quest corrections, if anybody didn't turn in yesterday. I think I got most of them. Why did I want you to do quest corrections before Friday? What's Friday?
Oh, there's so many tests.
Test or quest?
Quest.
What quest?
It's more like a practice test. It's more like a practice test. So Friday is going to be an endeavor quiz on all of our tests because we're going to finish our tests tomorrow, I think, in section 9-6. Tomorrow or Thursday. So you have to know your tests, right? Or else we're totally lost. So there's going to be an Endeavor quiz on Friday, and then we're going to have a practice test where I just give you series and see what you do. See how you do. Remember we did that on 9-1, 9-3-2? We had a practice one.
Wait, so is this one, wait, I'm confused. One is the one
So
that's
there's an
actually gonna
Endeavor.
count.
Well, Friday counts because it shows you how ready you are.
So is that?
So there's an Endeavor
Endeavor?
quiz that counts on Friday.
Okay.
There's an Endeavor quiz that counts on Friday. And then there's a practice test to get us ready for next week.
And the practice test is going into the quiz section or the?
No, it'll go into like assignment section. But we're gonna treat it like a test and see how we do, and then we're gonna go over the answers, if we have time Friday, but maybe even Monday. And then probably test Tuesday.
So if I find out to do surgery on Friday, can I do this on Thursday?
You could do the Endeavor quiz on Thursday, and you could take the practice test. And then, like, cause you don't necessarily need to be in here working on it, you know what I mean? Like, cause you're taking the practice test and just all these series and seeing, do I know what to do?
Okay. And then Monday you have a test, or is it Tuesday?
Tuesday probably. Cause Monday will be chapel, I think, right? Yeah, Monday will be chapel, and so we'll probably be going over that. And over the weekend, you guys will probably be working on the chapter 9 AP some more, because you'll have all these other tests that you can now do. Does that make sense?
Yeah.
You're having way too much fun at their happy. Yeah. Okay, I have 1, 2, 3. Ah, Hayuki, where's quest corrections? Ethan, where's quest corrections? Ethan, shoot.
Ethan finished. I think he just forgot to.
Did I turn it in?
Later.
So that means you're
Yesterday I
missing
saw
physics test?
his.
Huh?
Do
Does that mean
you
you're
have his
missing
number? Can
physics
you
test?
text him?
I don't know. I don't know. if it's
Just
gonna
ask
be
him
on
if he has
Friday.
it. If he has it, I'll be okay.
It's probably gonna be this week or next week.
Heidi, get that done for tomorrow, okay?
Okay,
When's our
I can
practice test
maybe
for
do for
It's not
after class today.
It's like a quiz.
Perfect. I'll be in your after school.
I
You
know
just
it
come
counts,
in
but
if you want.
Thursday.
All right, kiddos, what'd you do?
That's so stupid.
Did you do absolute value first, or did you just go?
Absolutely.
Yeah, I would do absolute value too, I think, right? So then we're considering, can I stop writing absolute value? Can I just say like 1 over n to the 4th? Is that okay?
Yeah.
Because we're considering the absolute value, which means we can ignore the negative 1. And I can say, what is this? Converging or diverging?
Converging.
Converging by?
I put alternate series.
Or P
By
series?
series.
P series, yeah, that's what I was going to say. By P series, because we're looking at the absolute value. So by P series, since P equals,
4.
and 4 is greater than 1, right? So what can I say without doing any more work?
It's absolutely convergent.
Absolutely convergent, and I'm done.
Really?
Uh-huh.
You
You don't even have to try it?
Pretty cool, huh?
Yes, that was.
Because if it's absolutely, it's absolutely. I'm done. So if absolute, that's why absolute value is nice to test first. Unless it's like, what was that one that we didn't test first? This one. Unless it's like nth term test, like number 2. So it's like, oh, it diverges right away. Otherwise, we want to check first of all absolute value. And if that converges, if absolute value converges, then absolutely convergent. Mandy.
Yeah, but since you use the alternating series test, the second one, an plus 1 is smaller than an. So
And it's supposed to be smaller, right? So if we had done alternating, this is true. If we had done alternating series, we could have said alternating series converges, but we still would have had to test, is it absolutely? I don't know. I still have to look at absolute value. Yeah. Yeah, so you can go the other direction too, but you would still have to test this one. One more page, right?
Is this test 7?
This is test. We have geometric, we have nth term, we have P series, we have integral, we have direct comparison, we have limit comparison, we have alternating, yes. Test 7. Absolutely convergent. How about this one? Negative 1 to the n minus 1 all over square root of n plus 3. do first, absolute value or alternating series test?
Just the alternating series.
A little bit of both. What'd you guys do? Absolute value or alternating?
Alternating.
You did alternating too? What'd you do, Layla?
Absolute value.
Absolute. We're tied, half and half. I think I might do absolute value too, to be honest.
But absolute.
Because you have to anyway, though. What's the problem? How would I do it?
Integral test.
Integral test. Integral test. I would need to, by integral test, positive check, decreasing check, continuous, yeah, -3 is not in there, right? So I could say then, by integral test, I'm gonna fill it in a second. So I'm looking at limit as b goes to infinity of 1 to b of 1 over x. What would that be? U is x plus 3, du is 1,
Yeah.
right? So I could say this is the same thing as limit as b goes to infinity,
2 square root
u to the -1/2, which would be 2 u to the +1/2. Of 2 square root of b plus 3 minus 2 square root of 4. Ooh, but as I go to infinity, where's this whole thing going to? Infinity. So therefore I can say by integral test, series diverges. Do you see that I'm testing the absolute value? I'm testing the absolute value, and I can't do p-series because it's not n to the, I can't do geometric, I can't do nth term because limit is 0. And so I'm considering first absolute value, so -1 doesn't matter. I have to do integral test. So I'm doing integral, I chose u to be so I just had u to the -1/2. And so u to the -1/2 plus 1 is u to the +1/2 divided by 1/2.
I get that, but like.
And then plug in b, plug in 1.
Yeah.
Infinity, so integral diverges, series diverges.
I get that, but like I don't get why use that when you can. I'm confused as to I guess how that's the absolute value test when you can I don't know.
Because I'm not just testing for whether or not the alternating series is converging, I'm testing how it's converging, absolutely or conditionally. So then I'm going to go ahead and you can do it in any order. So you guys who did this one first, that's okay. Because alternating series test, you would have done, first of all, the limit as n goes to infinity of a sub n does equal 0. Check. And then we would have done a sub n plus 1, so is 1 over square root of n plus 1 plus 3 would be n plus 4. And then a sub n. Sentence. Yeah, it's going to be less than, right? Because denominator is bigger. So then that's good. So the alternating series test tells me that it's converging, but how is it converging? Oh, then go look at absolute value. Since it diverges, it's conditional.
Okay.
So you can do it in any order. I just kind of like when the absolute value one converges. It's like, sweet, absolutely convergent. I don't have to do the alternating series test.
Okay.
But there again, if you do alternating series test the first time, if the limit is not 0, well then the whole thing is divergent. So there's pros and cons as to which one you start with.
Okay.
Does that kind of make sense? So then I can say, therefore, since the absolute value diverges and the alternating series converges, I can say my alternating series is conditionally. So what's different with alternating series is because, I shouldn't say because, there's another level to its convergence. And that's why I'm testing.
And then also, why do you use the, like I can see how the integral test works, but why do you use it instead of nth term test?
Because nth term test, the limit is 0, I know nothing.
Okay.
Does that make sense? Because nth term, I just take the a sub n, which is like the first step of alternating series.
Okay.
All right, number 6 is going to be a little bit interesting. So you guys choose which one you want to do first. It doesn't matter. Choose which one you want to do first, whether it's absolute value of or alternating series. But be careful.
Isn't it easy to test absolute value first?
In this one, to be honest, I would do alternating series first, but you could do absolute value still. You could do absolute value still. But for these, I've kind of trained myself to look for something first. And if that something is true, then I always start with absolute value. And if that something is false, then I just stop.
Divergence.
Uh-huh. What am I checking for that tells me, ooh, let's not do absolute value, or ooh, let's do nth term?
Like if they have the same at the top and the bottom.
Yeah. So I kind of, to be honest, every time I do kind of check the limit first. I do check this first. But I go and do absolute value just because that's the way I think of it. But I do check for nth term because right now if you look at this, well guys, if I was going to do the alternating series test first, or even if you just look at it, right, the first one, the limit as n goes to infinity of a sub n is 1. And since it's 1, it's not 0, then I can go straight to my series diverges, completely diverges, right? By the nth term test. So then those of you guys that start with alternating series, you might have seen as faster, whereas some of us, if you were doing the absolute value, you would still be going, trying to figure it out. Which if you did absolute value, you would still see nth term test and be like, oh wait, hey, it doesn't work at all, so it diverges, completely done. Did you have a question, kiddo?
Yeah, on
Yeah.
Friday,
Uh-huh.
is it gonna be on just the ones we're learning this week or from
Nope, the
all of
whole
them?
thing.
Cool.
Which is good because we kind of, I mean, we've been using nth term and p series, and we haven't seen geometric in a while because those are only really special ones, but yeah. So then all of us together, how do we do number 7? Would you do absolute value or alternating first?
I do alternate.
Yeah, you can do either way. You can do either way. I'm going to go back to my normal though. So then consider, and we're seeing him because he's nice and pretty, right? Absolute value which diverges by, what would you say, p series, p equals 1?
Series.
Yeah. Alright, now the absolute value diverges by alternating series. guys got conditionally? Now there is something that we haven't really been watching out for, and maybe we should have been.
Let me see, I have a question.
Yeah.
For this one, how can you know it's not absolutely convergent?
Because 1 over n diverges. So, and remember when I'm doing this?
Oh, you use, You
Does that make
use
sense?
Sears test first.
Yeah.
I didn't see, I'm sorry.
No, it's okay.
I just see the red.
Oh, yeah, I didn't see the black. Yeah. Otherwise, I would still have to test.
I thought you just used the,
And just set it without checking. Yeah. I couldn't have. You're right. Stretching?
Yeah. Sorry.
No. You're okay. All right. Let's do another interesting one. These ones are getting kind of boring now, right? Let's try an interesting one. How about this one? Although he should look familiar.
Yeah,
You
this
guys
one.
like this one?
Divergence.
do we need like 7 for this one?
So we can just do the alternating series.
Oh my god.
Just alternating series?
Well, doesn't it diverge?
Does it?
Wait, you have to do
What do you have to do? I'm seeing if you remember how to do.
1 over n.
Diverges because of the ln.
Because of the ln?
You have to change ln to.
Use an integral
No,
test.
1 over n
1 over n is...
is the, you're comparing.
Is the d.
I guess I could compare. Could I compare? 1 over n diverges, and 1 over n is greater than after n equals 1. Oh no, greater than diverging. I could do limit maybe. 1 over n diverges, and then limit would be 0. Oh no, 0, I need converging. I was thinking integral test.
Yeah.
I know, you guys don't like this one. You didn't like this one on the quest or anything. You didn't. I'm considering absolute value. We'll come back. So I need to consider integral test. Now, what am I not being careful of that I probably should be being careful of? Is it positive? Now, alternating is not, right? But I'm checking absolute value. So positive, yes. Continuous, ln has to be greater than 0, which is okay. N has to be not equal to 0, it's okay. And then as I plug in higher, it gets lower, so decreasing, it's okay. All right. Just because every now and then you're going to have one that's not okay, and we have to be careful of that, so we just need to watch out. But now coming back. What's u equal to? Do we remember? Good. Can you tell I'm trying to hit it home and make sure we remember? U is equal to ln x. Why is that so nice? Because du equals. So 1 over x dx is just du. So I just have 1 over u though, right? Because u is in denominator. 1 over u, and then 1 over x dx is just du. 1 to b. Of ln of u, and ln of u is ln of x. From 1 to b. Yeah, you guys can probably see it by now, right? This would be ln of b minus ln of, oh, not 1. Oh, no. That would be bad. 2. ln would not exist if it was 1. There we go. And maybe you guys can see it, but if it was ln of 1, that would be 0. ln of 0 does not exist. That's why they're starting at 2 instead. But then as b goes to infinity, that goes to infinity. So therefore, integral diverges, right? And since the integral diverges, then my series diverges. So now I'm checking for conditional, right? What's the limit of a sub n? Yep. And then a sub n plus 1. And a sub n. For 2 or anything higher than 2, ln will be positive and getting bigger, and that's going to be getting bigger, which is going to be always bigger than that. So therefore, check. Yeah.
When the bigger thing here, do you mean as in like the bottom?
Denominator will be bigger, which means number will be smaller.
Okay, so the number is what matters.
Yeah.
That's less than. Okay.
Yeah. But I'm considering my denominator because that's the clue.
Okay.
Where would you guys start in number 9?
Can you flip it over?
Flip what over?
Like to make it 2 to the negative 1? Or is that not?
Well, I could do 2 to the negative n. I don't know if that helps me. It is alternating, right? It is going back, forth, but what's special about number 9?
Oh, isn't it geometric?
Is it geometric?
Yeah.
How can you tell?
Because the power is n.
The power is n. So a couple ways of telling. I could go ahead and start plugging in and say, wait a minute, it's going to be negative 1 to first power, 2 to first power, negative 1/2 plus second power, positive 1/4 plus negative 1/8 plus, that's geometric, right? Times 1/2 times 1/2 times 1/2. So couldn't I rewrite this to be do I even need to think about him as alternating? Because what can I say? Converges. Wait, hold on. If he converges by geometric series test because r is equal to negative 1/2, is that good if r is equal to negative 1/2?
Yeah.
It is, right? So I could say not just converges, what could I say?
Absolute.
If they asked me, I would say absolutely convergent. Now, if you don't like me saying that, you could have thought of it as absolute value, which would have been 1/2 to the n instead of negative 1/2 to the n. And then you could say absolute value is convergent, so therefore the whole thing is absolutely convergent. But you could also think, wait, this is just geometric series test. I know that this is convergent and not conditionally. It's convergent, like all the way. That's how we could maybe think absolutely convergent. By geometric series test, since r is equal to negative 1/2, and technically, if I was doing it the old-fashioned way, right? So just to kind of show you, wait a minute, geometric series could have said yes. And when it says yes, it says absolutely convergent yes. Does that kind of make sense, guys? You could have still done absolute value, and you would have said yes, converging, and then you could have done alternating series and said yes, converging. Well, if absolute value is converging, then absolutely convergent, right? Or you could have thought, wait, geometric series, I don't even need alternating. I can just say, yes, r is negative 1/2. Done. Good. Oh, you guys are already scared for number 10.
Yes.
Ruh-roh. Ruh-roh.
It hurt.
Piecewise function.
It hurt.
Piecewise function.
Two of them.
Here we go, here we go, here we go. We got it. We got it. We got it. We got it. Number 10.
Oh, you break it into.
Let's use our strategy.
Do you do each part separately?
Can you do each part separately? Can you do each part separately?
Don't you have to?
Just check both of them are converge or diverge. So
They both
do part by part.
If I'm thinking to infinity, is it a property of summations that I can take? But wait a minute, this is odd, so it would be every other. It'd be 1 and 3 and 5 and 7. What about 2 and 4 and 6 and 8? And this one is only 2 and 4 and 6 and 8. What about 1 and 3 and 5 and 7?
Just
Can I make a summation be only odds or only evens?
yeah.
How? Doesn't summation by definition go 1, 2, 3, 4, 5, 6, 7?
Plus one. And because it's oh yeah.
You have to like totally change it though, right? I don't know if we want to totally change it. What if, for bad ones, I think about plugging in? What if? So what if I plug in 1? What do I get? Well, 1 is odd, right? So odd would go here. Plug in 1. 4 over 1 plus 1, 2, right? All right, now n is 2. Now n is even. I plug in 2. Well, negative 2 over 2 is going to be negative 1. Plus 3. 3 is odd, so 4 over 3 plus 1, 4 over 4. Plus 4 is even. Negative 2 over 4. We're going to go a little bit further. 5. 5 is odds, so then plus 4 over 5 plus 1 is, yeah, you're right, 6. 4 is 6, that's gross. 2/3. Plus
Negative 1/3.
6 is even. So then plugging into bottom one, negative 2 over 6 would be negative 1/3. 7 is odd, so then 4 over 7 plus 1. 8 is even, negative 2 over 8. Now technically, right? Is there another way? Now you guys were thinking of, okay, split up, and then, well, but if I split up, I have to make only evens, only odds. How do I do that in sigma? When it goes 1, 2, 3, 4, 5, 6, how do I make it just 1, 3, 5, 2, 4, 6? I don't know if it's the best strategy to make a brand new a sub n formula because those are complicated. But could we look at this and maybe come up with a new series that means the same thing? They gave it to me all complicated, but 2 minus 1 is 1. 1 minus 1/2 is 1/2. 2/3 minus 1/3 is 1/3. 1/2 minus 1/4 is 1/4. What is this the exact same thing as? 1 over 1, 1 over 2, 1 over 3, 1 over 4? huh? Good, Yoshi. Same thing. No, they gave it to us. It was so gross. Same thing. So this isn't even me using any like convergence or divergence test. This is me saying, that's gross. Is there another way of looking at it? And then saying, oh. And then do I even need any sort of alternating this, that's, or the others? Nope. I can just say diverges completely by P-series test. Good. Since P equals 1. Gnarly, huh? Make it possible. Because we can't split up. Because it still have to go by 1, 2, 3, 4. But I can't just go odds, just go evens. But I can look at the whole thing and see, is there a better way of looking at this? Is there a better way of looking at this? So then, you guys try number 11. Let's see, maybe it's not too bad after all.
But why is
Yeah.
Huh?
Have you seen Who
Oh,
Framed
why is it
Roger
equals to
Rabbit?
1 and the other
About-
one
of
is
Uh-huh.
equals to 2?
To 2?
Yes.
You mean negative 1/4?
No. P equals to 1 and P equals to 2.
Which is why we're not trying to consider together, we're trying to consider apart. Like we're not trying to consider back, forth, back, forth, back, forth. We're trying to think of what is it all together. You see what I mean? Now guys, sadly, you can do convergence and divergence of this whole section. This is all just like warning you of what might happen, and it'll be a funny homework thing that we'll look at. There is one other piece in this section that has to do with estimating remainders and errors. Homework, I want you to do everything converging, diverging. But if you start seeing estimating remainders or errors, stop. Okay, so tonight homework, this is like 2 pages. It's 2 examples, we just didn't get to it, but I thought it was better for us to practice convergence, divergence. So do everything in homework, convergence, divergence. If there's something about estimating the sum, stop. Stop, okay? You're good. Do you see any estimating the sum? Stop, 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 stop.
上次发我的经济答案。
Wait, number 11 doesn't work. Hold on.
Have you seen Who Framed Roger Rabbit?
I think I saw part of it once. I'm looking at the, what do you mean?
Good.
Oh, wait, number 11.
The last one
Have you seen Who Framed Roger Rabbit?
We wouldn't be able to do this example yet.